Today's Daily Dose of Math is two quick examples of graphing a step function using the parameters. I have another video which is graphing a step function using parameters, which goes into detail, but I want my students to be able to see more examples. So this video will be two examples where I quickly go through the process. Here we have the function f of x equals -3 square brackets with 1/2 x plus 4. It is a step function, it is in this form, but the h isn't showing. A is -3, b is 1/2, k is 4, I can see that easily. I'm going to rewrite this so that we can more easily see what our h is. We get f of x equals -3 square bracket, and then I replace this x with a bracket, x minus 0. And now we can see that our h is 0. The student doesn't have to show this step. If a student's familiar with the process, they look at this and they realize that means h is 0. So hk, in this case, is 0, 4. And I can put a dot on my graph at 0, 4. hk always gives you the position of one of the closed circles on your curve. The next thing to do is to look at parameter b. b equals 1/2. We have to know that the absolute value of b is equal to 1 over the length of the steps. The absolute value of 1/2 equals 1/2. Therefore, the length of steps is 2. I'd like to start drawing my steps at this point, but I don't know yet the height of the steps. I don't know whether the staircase is going upstairs or downstairs. And I don't know whether the closed circle is on the right or the left side of the step. So I have more things to get from my parameters. The next thing to look at is the sign of b. b is 1/2, which is positive. When b is positive, it means that the closed circle is on the left end of the step. Since I know that this closed circle has to be on the left end of a step that is 2 units in length, I can draw the step. I go 2 units to the right from that place, and I put an open circle there. I have succeeded in drawing my first step, but I can't draw any of the other steps yet because I still need to know the height and whether this curve is going upstairs or downstairs. To get the height, we use the absolute value of a. The absolute value of a is equal to the height. A is -3, so the absolute value of -3 is 3, and that is our height. The height of steps in this curve is 3 units. So I know there's going to be a step 3 units below 4, which means there'll be a step where y is equal to 1. 3 units above 4, so there'll be a step where y is equal to 7. The last thing I need to know is whether the steps are going upstairs or downstairs so that I can draw these steps. AB gives me my slope. The slope of the imaginary line that's connecting all of the closed circles on the different steps. AB is equal to, in this case, -3 times 1/2, which is -3/2. It's negative. That means that this imaginary line is tilted downwards. We have a negative slope. That tells me that 3 units below here at y equals 1, I will have a closed circle right below this open circle. And then I can draw a 2 unit long step and put a closed circle. That allows me to finish drawing the rest of my curve. There will be an open circle here 3 units above this closed one, and then there will be a step going to the left by 2 units. That's everything I can fit over here. And over here, 3 units below y equals 1 is y equals -2. There will be a closed circle right here. And it will extend 2 units to the right to an open circle. And that's all I can fit on this graph the way I've drawn it right now. So that is the first of our 2 quick examples of graphing a step function using the parameters. The special thing that happened here is that our h was equal to 0, which made the equation look a little different and resulted in a closed circle being right on the y-axis. We also have a situation where the steps are closed on the left, open on the right, and where our staircase is going downstairs, we have a negative slope. I will quickly replace this with a different example, and we'll get our second example of the video. Okay, so I have a function where a is equal to 3/2, b is 2/3, h is 2, k is 3. The first thing I'm doing is hk, in this instance, is 2, 3, and I need to put that dot on the graph. That's going to be here, and that's going to be a closed circle. Next, the absolute value of b equals the absolute value of 2/3, which is 2/3. Now this is equal to 1 over the length. Therefore, since 1 divided by 3/2 is 2/3, the length is equal to 3/2. Or 1.5 if you prefer decimal. The sign of b is positive, so we have steps that are closed on the left. I have a length of 1.5, and this step is closed on the left, so therefore it will go to here. It's going to the edge of my graph. I've finished my first step. I have to do some more work to figure out what to do for the next step. The absolute value of a is equal to the height. In this case, the absolute value of a is the absolute value of 3/2, which is 3/2. That's our height. Again, 1.5. So there will be a step 1.5 units above this one. There will be a step 1.5 units below it. I need to find out the slope before I can draw that next step. AB is equal to 3/2 times 2/3, which is 1, and it's positive 1. So the slope is positive. That means we are going upstairs this time. That allows me to start drawing my other steps. 1.5 units, the height, below y equals 3 is going to be at y equals 1.5. So there will be an open circle here. And then I draw a step 1.5 units to the left of that. And I put a closed circle at the other end of it. 1.5 units below y equals 1.5 is y equals 0. It's on the x-axis. So there will be an open circle right on the x-axis here. I'll draw it nice and big so that we can see that it's open. And that will stretch 1.5 units again to a closed circle right here. 1.5 units below that, another open circle, stretching 1.5 units, closed circle. And 1.5 units below that, there will be an open circle. And I'll show the beginning of that step, but it's going off of the graph as I drew it. I have drawn enough steps here so that we can see the pattern, and anyone who's reading this graph will be able to figure out what's going on and be able to answer questions even if they don't have access to the equation. So that is 2 quick examples of graphing a step function using the parameters. That is today's Daily Dose of Math. Please like, subscribe, and share.